All right, folks, it's Bass Action, back in action here. On these three windows of our green foldable, my page isn't green, but yours would be, we are going to look at the properties of rectangles, rhombi, that's going to be our plural of a rhombus, and squares. So the first thing that we're going to start with is our rectangles, and what we want to remember about a rectangle is that our definition for a rectangle, and we can kind of even jot it down, our definition for our rectangle is that it's a parallelogram with four right angles. That definition alone is going to give us our first two major properties. So for the rectangle, since it is a parallelogram, it is automatically going to have all the parallelogram properties. Now, my video here, my display actually still shows those 5 parallelogram properties up here, up above. So as soon as you know you have a rectangle, you automatically have all of these properties from up above. So just by listing all parallelogram properties, it automatically counts for 5. Now, it's going to be a parallelogram with 4 right angles. So that's going to give us our next property. We're going to identify that it has 4 right angles. Now, this isn't going to come as a huge surprise to us, so let's go ahead and mark several things. We can go ahead and mark these right angles. We can also mark most of our parallelogram properties, but I'm not going to quite mark all of them. I'm going to indicate my parallel sides. Both pairs of opposite sides are parallel, and I'm going to mark my congruent opposite sides. Okay. Now, the next property that we're going to list is the fact that the diagonals are congruent to each other. Now, that's a property that you might not be familiar with. Your middle school and elementary teachers certainly might not have told you that one. So the diagonals are congruent. Now, what we know from our parallelogram is that the diagonals bisect each other. So now what we have are congruent segments that are also bisected. So let's go ahead and draw in our diagonals. So we can draw these in. And if you're not 100% certain that those diagonals are congruent, although I certainly feel like they look like it, you can go ahead and just take out your compass or any kind of a straight edge and actually just measure them. Show that yours are actually congruent. So if they're congruent and they bisect each other, what we're also going to get is the fact that all 4 pieces now of our diagonals are going to be congruent to each other. So all 4 of these get the exact same marking, which is not what happened on just a basic parallelogram. Now, the next thing that I want you to notice with the fact that all these are congruent goes to our question right here. What kind of triangles do we get? Now, I've got this letter P in all of these, and that P we can label in our picture is going to be this point of intersection right there is that P. So if we look at those triangles and we look at the markings, what we should be able to notice is that all of those triangles turn out to be isosceles. Okay. And we already marked it in our picture. The other question, what do you know about the parts of the diagonals, is that we're going to indicate that all 4 parts are congruent. Now, the other thing that we can do is we can mark some congruent angles here, but instead of using our normal congruent markings for our congruent angles, I'm going to do something a little bit different on this, and it's going to make things easier for us to keep track of. We're going to use some color-coded dots. So I'm going to first look at these 2 triangles that are across from each other right here. These 2 triangles are going to be congruent to each other, and we can certainly get that because they both have these congruent parts, and then we have our vertical angles. So the triangles are going to be congruent by side angle side. So what I'm going to go ahead and mark, and also combining the fact that these are isosceles, is that these 4 angles are going to be congruent. So this one, this one, this one, and this one. All 4 of those angles are going to be congruent to each other. I'm also going to mark then the 2 triangles that are up and down. Those triangles are congruent, and of course they're isosceles, so their base angles are going to be congruent. So these four angles are congruent to each other. And I typically just mark those four little dots. I feel like the colors are a little bit easier to follow. And then when I'm trying to figure out what angles are congruent to what, it's just a lot easier for myself to follow there. Okay, so that's all I've got for rectangles. So let's go ahead and take a look at our rhombus. Our rhombus is going to be a parallelogram with four congruent sides. So just like we had with our rectangle, we're automatically going to fill in and state that all the parallelogram properties are going to hold true. So just like with the rectangle, we automatically get 5 properties. Now, if a rectangle or if a rhombus is a parallelogram with 4 congruent sides, that's going to be our next property, is that all the sides are congruent. So on our parallelogram, we just had opposite sides congruent, but now we're going to get all 4 sides. So let's go ahead and mark that. So again, I can mark my parallel sides. It's always good to mark those, remind ourselves. But now I can just put a single tick mark on all 4 sides because all 4 sides are congruent. The next property that we're going to mark is also going to be about the diagonals. And from our parallelogram, we know that the diagonals bisect each other, but you can clearly see, even measure them with a straight edge here. You can even measure them with your fingers and just show that those diagonals are not congruent to each other, but they do bisect each other. So I can mark the pieces congruent, just like we did with a basic parallelogram. But the additional property that I get related to the diagonals for a rhombus is that the diagonals are actually perpendicular. So go ahead, check it out. Take a either just take a corner of a piece of paper and tuck it right here in this little angle here and show it's a right angle. You could measure it with your protractor as well, but we definitely can label this as a nice right angle. That means then that actually all 4 of these triangles are going to be right triangles, so our Pythagorean theorem would always hold true. So we can write ourselves a little note that we can always use our Pythagorean theorem because we automatically get those right triangles. Now, the last property that we're going to list is the fact that the diagonals, and this we're going to mark this special, the diagonals are going to bisect the opposite angles. Now, a good way to contrast this is that if we look at our rectangle, what we noticed is that these 2 angles here were different, okay? We had different colors, those were different angle measures. But when we work with our rhombus, what we're gonna find is, for example, angles 1, 2, 3, and 4 are all going to be congruent to each other. And again, I like to do the dots instead of the traditional congruent markings. That also means that angles 5, 6, 7, and 8 are going to be congruent to each other because the original opposite angles were congruent and then they were bisected, so we get 4 congruent parts there. So those are going to be our properties for our rhombus. The last little note here is notice that these angles 1, 2, 3, and 4 are congruent, and 5, 6, 7, and 8 are congruent, but they are not congruent to each other. All right, lastly, we're going to look at our square. And on our square, our definition is going to be a parallelogram with 4 right angles and 4 congruent sides. Well, if it's a parallelogram, it's going to get all the parallelogram properties. If it has 4 right angles, that makes it also a rectangle. So it's going to have all the rectangle properties. And if it has 4 congruent sides, it's going to have all the rhombus properties. Now, because of this, we can mark our square in a pretty particular way. We can mark our parallel sides just as we've always been doing. That part's not going to change for us at all. We can mark all the sides with a single tick mark because it's a rhombus, so all 4 sides are congruent. We can mark each of the corners as right angles because it's a rectangle. We can mark the diagonals perpendicular to each other because it's a rhombus. We know that the diagonals are going to bisect each other because it's a parallelogram. The diagonals are going to be congruent to each other because it's a rectangle. So all 4 of these little pieces are going to be congruent to each other. And because it's a rhombus and the diagonals bisect the opposite angles, and we already knew that those opposite angles were 90 degrees, we actually know that each of these little angles is 45 degrees all the way around the rhombus. So we automatically know exactly these angle measures. There's no question exactly what they're going to be. So when we're marking our square, this is the way we're going to mark the square as opposed to with the multiple marks from before. So you may want to rewind this part and re-listen to where each of those properties came from. Get comfortable with those because we're going to apply those when you get to class.